Okay, so we're back talking about some of the sample problems that you've got in your Blackboard shell over graphing, and there's a handout that goes along with this. I was going to show you some of the features of the graphing calculator. I'm using an app on my smartphone called Calculate 84. It was a free download, so I like that one. You're welcome to use that or any of them, or you don't have to use this method at all. But I thought I'd show you some of the graphing features in case you wanted to. We're on number 2 of your handout. 5x plus 2y equals 10. So if you want to pause the video and try this before I go over it to practice what we just learned in the last video. But first thing I would do is I need to solve for y, and that's what I've done over here. You can check out the steps. You need to get it in y equals form. That's your mx plus b form, where you've got your slope in front of x and the y-intercept. And the graph sort of looks like this. I've already got that in. Now I'll mention something here because you might make the same mistake I made, is I used my subtract sign, and I'm kind of bad to say in math class that subtract and a negative sign sort of are interchangeable, but on my calculator evidently they're not. So I'd use my subtraction button, and I needed to use the little minus button you see down here. Can you see that? The minus button. So whenever I typed in negative 5 over 2x, I did need to use this subtract sign, so just be aware of that. That could happen for you as well. I had to think about that for a while and I got it to work. So, all right, so you've typed in this equation, negative 5 over 2x plus 5. We do notice that it is a negative slope, so it should be going the other way from the last example, and should have a y-intercept at 5, positive 5, above the x-axis. All right, can you list the x-intercept? Question 1. So we can do that a couple of ways. One, we can hit graph and just look at it, kind of cursor over it and say, where do I think it crosses the x-axis? Like so. It looks like it's around 2-ish, but I'm not sure exactly. How about the y-intercept? Again, put it on the y-axis. It looks like it's at x is 0. It's around 5. Now that, again, it's not exactly right. For some reason, it's the pixels or something. Can't pick it up exactly right sometimes, but it gets you pretty close, an idea. So it's around 5. The way to know for sure, a couple of ways. You could do the algebra. If you plug in x is 0 to see this equation, when x is 0, 0 times whatever's in front of it disappears, and y equals that constant. So that's your y-intercept. To figure out your x-intercept, you let this side be 0. Y equals 0. We throw the 5 across the line, and we can solve that. Another way is to go to your table of values. Oh, and there's a 0. When x is 0, there's my y-intercept, and here is my x-intercept. When y is 0, you're looking at the x-intercept. So that's another way to tell. Now, if your answer is a fractional amount, this may not pick that up. You may have to go into the table setup and have it count by 0.5 or something so that you get more values, and that may be exhausting too. It may be just quicker to do the algebra and plug in y is 0 and equation solve that to find it. But if it's a nice crisp number, like a nice integer answer like this one, the table will pick that up nicely. So there's your intercepts. List 3 points on the graph, so we can do that all day long. 4, negative 5, 5, negative 7.5. Just all of these would be x, y sample points that would be along this line. There are infinite of them. They just keep going. Not sure how far it would go before I exhaust out of doing that, but plenty of points to pick from. So list 3. What are your thoughts about the slope? And you should see it's a negative slope, and it's a medium grade slope, kind of a steeper slope. Let's see, what do you think? Yeah, when I look at it here instead of my little drawing, it's a pretty steep slope, I would say. Exactly, it's negative 5 over 2, which means it has a rise of negative 5 to a run of 2. So it's steeper than just a grade of 1, because you're negative 5, or if you thought about it even from the positive side, you're going 5 vertically in comparison to only 2 horizontally. So there's a lot more up than there is over. So I would say steep. Domain. The domain of all of these linear equations is going to be negative infinity to positive infinity. And so is the range. A couple of ways to know that would be from looking at the table of values and kind of analyzing that and thinking, what can I plug in for x? What can x be in this equation? Is there any restrictions on X? Do I get any error readings maybe over here on the Y side? And you do not, and you shouldn't. Of course, this, not exhaustive because we don't have all the values, but it looks pretty good. Like X could be about anything. And also just thinking about a linear equation. What can you plug in for X and get an answer for Y? And there's no restrictions. The other thing to know is when we look at the graph, there should be arrows. If we were drawing this on our graph paper, it goes on and on. We're only seeing the 10 by 10 slice of the graph, but it continues on, and we know lines are like that. There's arrows that keep going both directions. So we would say it goes the X value, which the domain is the X, the horizontal axis, the X-axis. There are values for X equals, say, -10. There's a value this is going to hit. We can't see it right now, but we could plug it in our algebra and see it, but we can't see it on this graph. So X is -10. Looks like that's going to run into it. And if X is negative anything, the graph keeps going up. So there's X values to -infinity, and then the same story could be true over the positive side. At X is +10, it looks like there's a value down here it hits. There is. And we just kind of can know on the domain and range for the lines that it's -infinity to +infinity. So you would write that like this. Domain -infinity to +infinity, which is our way of saying anything goes from the X-axis. The same thing is going to be true for the range, the up and down. It goes up and down without bound as well. And then this next question, is it a function? Is it a function? A function is defined as a relation in which no X values are repeated, or another way to think of it is for every first component, the X value, there's exactly one corresponding Y value, which is a fancier way of saying no X can be repeated, that it can't turn around like when the graph turns around and it has a repeated like one X here with two different values up and down from it. That doesn't happen on a line. If you draw a vertical line, that's another way to tell. A vertical line can only hit this graph one time. There's no turning around and having double values at one X value. So yes is your answer there. Yes, lines are always functions. Unless the exception would be if it's an absolute vertical line. X equals a constant, like X equals 2 is a vertical line in and of itself. So that one's the only exception. That is not a function. And an example of that would be like X equals 2. X equals a constant is a vertical line in and of itself. All right. Then check on your neighbor. If we were in class, I would have you work in groups maybe and check this out. All right, let's do the next one. We're going to do a parabola next. So type that in your Y equals feature. Let's clear that and type in X. You've got a little squaring feature there, and then -4. Okay, type that in, hit graph, and notice it is a parabola. It's a U shape. And that's what we should expect on all these quadratic equations. Y equals a quadratic makes a parabola every time. It might be flipped upside down or moved over left, right, shifted around on the graph, but it's always a U shape. So list the X-intercepts. Let's see. Table values. Let's see if I can get those that way. X-intercepts when Y equals 0. Here's 1. Y is 0. One of the X-intercepts is at -2. And then maybe look through this way. Sometimes this will work for you. Here's another 0. Y is 0. X is 2. So those are our two X-intercepts. How can you write those? It's X is 2 when Y is 0, and X is -2 when Y is 0. So two values. You might put a comma between them depending on how the question is phrased. Another way to tell, looking at the graph and tracing along, kind of looking at it that way. And then the other way, the fancy way, if you're having trouble finding it, if it's not a neat point, these are nice integer points, but if it was a fraction or decimal amount, remember we have to go to calculate and then find 0, and it asks you to go to the left hand. Let's say I'm going to think about that one. I put my cursor to the left side of that, hit enter. Then I move my cursor over to the right hand side of that, hit enter, and then it gives you the number. Well, shucks, it didn't give me exactly -2. We talked about how it doesn't come out always perfect, when you're tracing, but it didn't here either. It was -1.999, really close to saying -2. Should say -2. Okay, then we could do it again for the other 0. Let's do calculate 0. Left hand bound, I'm going to do this x-intercept, try to figure that out. Let's see if I have more luck with it. And then trace to the right hand side of that, hit enter. This one did give me exactly 2. That's what it should be, is 2 and -2 are my two x-intercepts. And notice it should have 2 x-intercepts. The parabola can have up to 2 solutions. And we could use this actually to solve our quadratics that we did in chapter 1. The solutions are the x-intercepts. All right, so what about the y-intercept? So we can cursor along and maybe get close to seeing where that is. Looks like it's about at should be at negative. Oh, let's get out of this feature, just regular graph. Should be about at -4. And I can tell I'm sort of close to that. To tell, you can go to your table values. Oh, there it is. At x is 0, that's your y-intercept, so at -4. The other way to tell is just plug in x is 0. Just do the algebra. I fall back on that, I guess, because I'm an algebra teacher. I'm real comfortable doing just plugging in the values for the x and the y and just doing it that old way. But when x is 0, 0 squared is 0. 0 minus 4, y is -4, and you can get it right there. Find at least 3 points on the graph. We could do that by looking at our table and list any number of these, -4, 12, -3, 5. You can list values all day long. What are your thoughts about the slope? What do we think about this slope? It's not like our line where it's just one straight, one slope, constant slope. The slope is ever changing. We have a positive side of this, and then we have a negative slope. If you put your pencil along this, that's how we determine the slope, is by laying a pencil tangent to any point along it. And my pen is going in a negative direction. We'd say that's a negative slope. So there's a negative slope on that side and a positive slope, on this side. So it has varying slope. And then whenever we move along it, we might even have a 0 slope at the very bottom where it hits its minimum. So the slope is ever changing along the curve. You might be asking your homework to name the increasing and decreasing part of the function. The increasing part is the part that's positive, and the decreasing is the part that's negative. And we list those according to our x-axis. So it looks like 0 is where it turns around. So from 0 on over, I would say it's increasing. And from this side, -infinity to 0, it's decreasing. And then domain and range. The domain, you can't see it on the screen, but there's arrows that keep on going. So it opens up left and right. It keeps going in the left direction as well as the right direction. So the domain is -infinity to +infinity. And the range does have a lowest point. That minimum point where it dips down was at -4, and it touches there at -4, including that on our t-table. So we want to bracket to show that we understand that it includes the point -4. And it is a function. The vertical line test works to show that it doesn't have any x's repeating. You can only hit that graph once with a vertical line. Let's see if we have time to do one more. Okay, next I'm going to do number 4, which is the square root of x minus 1. So we want to type that in our y equals. You can clear that out and do, where's my square root? Square root of x subtract 1 and hit graph, and we could analyze it as well. It's still a function. The vertical line works. Its domain starts at 1 and goes to infinity. So we could say, I'm going to speed this up, I'm going to run out of time. 1 to infinity, and its range is 0, the lowest y value, and then up is 0 to infinity. So we could talk about all those things and use this feature as well. One last example. How could we do number 5? Y squared equals x. So y squared equals x needs to be solved for y. So how do we get at y equals? We have to square root each side. So when you square root the squaring, it makes y, but you have to say plus minus when you're the one that brings the square root into the problem. So we really have two equations, positive radical x and negative radical x. So we've got two parts to type in. So we do get to use two of them this time. Let's do square root of x, and I'll move down here. Make sure you use your negative square root of x. Okay, so when we hit graph. It graphs, the first one is this curve up here that we kind of talked about before, and then the negative one is its mirror image below. So we have kind of a sideways parabola, and I just wanted you to see one that's not a function since we show so many examples of functions. Here the vertical line test would hit that twice. About any place you draw it over here on this side, not a function. So it's no. It's still a relation, it's still a fine graph, but it's just not a function. Domain would be 0 on over. And range, it opens up and down. This one is opening up and down without bounds. So negative infinity to positive infinity. We could still look at those intercept idea, but I did want you to see how to do one that wasn't a function. In general, when y is raised to even powers, this kind of thing happens. You get a repeated x. If we were making t-tables, and let's look at that t-table, by the way. We've got some error readings because not everything is in its domain and range. That's what it looks like when that happens. But we have repeated x values. We have this x9 going with 3 and x is 9 going with negative 3. So we have a repeated x as well. We can see that on the table. All right, so I hope that helps, and best wishes.